Assalamualaikum warahmatullahi wabarakatuh. My name is Wa'am Fikri Daniel bin Muhammad Fauzi and my metric number is 10DE22F1034. I will talk about agenda and the conclusion.
Assalamualaikum and very good morning. Hi, my name is Muhammad Irfan Rafiq bin Muhammad Izam and my metric number is 10DE22F1038. I will talk about the example of application of differentiation in real life.
My name is Apinat Anak Lelaki Somai and my matrix number is 01DEE22F1057.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Fikri bin Wahdi. My matrix number is 01DE22F1056. So I will talk about the conclusion and the calculation.
So let's talk about our agenda for this video, which is introduction, example of application of differentiation in real life and calculation for the question.
The introduction of differentiation. Differentiation is a process or a method of finding the derivative of a function, or also can be defined as a derivative of a function with respect to an independent variable.
I will talk about the example of application of differentiation in real life. For the first one is calculating profit and loss with respect to business using a graph. Second is explanation of the rate of change of moving body. And the last one is the calculate to rate of change of temperature.
So let's move to the question. The first question that we choose is y equal to 3x cubed minus ax squared plus 5. Use differentiation to find expression for dy over dx. So how to solve this question? Firstly, we need to bring down the power which is cubed to multiply with whole number and the power need to minus 1. So we get the derivative of function is 9x squared minus 16x. Next question is find the coordinate of any stationary point on the course. As we know, the station point or turning point at dy over dx equal to 0. So we factorize the equation to get the value of x, which is 0 and 16 over 9. After that, we need to substitute the value of x into the y-x equation. Since we have the value of x, so we also have the coordinate of stationary point. The first coordinate is 0 and 5. The second coordinate is 19 over 9 and negative 833 over 243. Next question is how many stationary points does the graph have? As we get the answer for the previous question, we have got 2 stationary points. Okay.
Next question is we need to find the x-intercept and y-intercept point. When we need to find the value of x-intercept, we need to use y equals to 0. So settle the equation for y equal to 0. We get the x-intercept is 1. 2.4 and negative 0.7 for y-intercept. We need to use x equal to 0. So we replace the x with 0 and we get the y-intercept is 5. Next question, to determine the nature of any stationary you found in part 2, justifying your answer. So firstly, we need to find the d square y over dx square, that is, we differentiate again for the dy over dx equation. We get the d square y over dx square is 18x minus 16. Next, we substitute value of x that we get at question 2 into d square y over dx square. When x is 0, we get the answer is negative 16, which is smaller than 0. So the coordinate is 0, 5 is a maximum stationary point. Next is when x is 16 over 9, we get the answer is 16, which is greater 0. So the coordinates 16 over 9 and negative 833 over 243 is a minimum stationary point. For the last question, is sketch the graph of the curve since we have the minimum and maximum point, x-intercept and y-intercept. So this is our graph. We have two same graph. One is handwriting graph and the other one is digital graph.
Okay, for my part is I want to discuss about the second question. The second question that we choose is y equal to negative 4x cubed plus 2x squared plus 5x plus 1. Use the differentiation to find expression for dy over dx. First, we need to bring down the power to multiply with front number and the power need to minus 1. So we get the derivative of function is negative 12x squared plus 4x plus 5. Okay, for the next question is find the coordinate of any stationary point of the curve. As we know, that's the stationary point of turning point as dy over ds equal is 0. So we factorize the equation to get the value of x, which is negative 1 over 2 and 5 over 6. After that, we need to substitute the value of s into the y equation. Since we have two value of x, we also have two coordinate of stationary point. The first coordinate is negative 1 over 2 and negative 1 over 2. And the second coordinate is 5 over 6 and 229 over 54. Okay, next question is how many stationary points does the graph have? As we get the answer for the previous question, we have got two stationary points.
Next question is we need to find the x-intercept and y-intercept point. When we need to find the value of x-intercept, we need to use y equals to 0. So we settle down the equation for y equals to 0. We get the x-intercept is negative 1 over 2, negative 0.4 and 1.2. For y-intercept, we need to use x equal to 0. So we replace the x with 0 and get the y-intercept is 1. Next question, to determine the nature of any stationary you found in part 2, justifying your answer. So firstly, we need to find the d square over dx square. That is, we differentiate again for the dy over dx equation. We get the d square y over dx square is negative 24x plus 4. Next, we substitute value of x that we get at question Roman 2 into dx square y over dx square. When x is negative 1 over 2, we get the answer is 16, which is greater than 0. So the coordinate negative 1 over 2 and negative 1 over 2 is minimum stationary points. Next is when x is 5 over 6, we get the answer is negative 16, which is smaller than 0. So the coordinate 5 over 6 and 229 over 54 is a maximum stationary point. Last question is sketch the graph of curve since we have the minimum and maximum point, x-intercept and y-intercept. So this is our graph. We have two same graph. One is handwriting graph and the other one is digital graph. For the conclusion, our presentation has proved that the differentiation can help in the introduction of new concepts in mathematical and make things more easier to measure or investigate and help in new discoveries. That's all from us. Thank you.